Exercises of series. Evaluate the following series. This means, is the following series convergent or divergent? Let's take this series. It's a geometric series because from here to here we product by 1 over 3, and also from here to here we product by 1 over 3, and also here. So this is equal to, let's take 1 over 3 outside. So it's 1 plus 1 over 3 plus 1 over 3 power 2 plus 1 over 3 power 4 plus etc. without stop. Let's remember the rule that sigma a power n from 0 to infinity is equal to 1 over 1 minus a f. We suppose a between minus 1 and 1. So the number 1 over 3 here, it's between 1 and minus 1. So this is equal to 1 over 3 times 1 over 1 minus 1 over 3. So it's 1 over 3 times 1 over 2 over 3. So the final answer is a half. Next exercise. We have here also geometric series where the product by minus 1 over 10 each time. So this is equal to, and this number is between 1 and minus 1. So we can write this 1 over 100 times between parentheses 1 minus 1 over 10 plus minus 1 over 10 power 2 plus minus 1 over 10 power 3 plus etc. So it's 1 over 100 times 1 over 1 minus 1 over 10, 1 minus minus 1 over 10. So it's 1 over 100 times 1 over 1 plus 1 over 10. So it's 11 over 10. So after cancellation, you will have here 1 over 11 times 10. So 110. The next exercise, here we have 1 plus 1 plus 1 over 2, 1 over 6. Remember that 2 is 3 factorial, 4 is 24, 4 factorial, 125 factorial. And this is 1 over 1, and this one is 1 factorial. Here 1 over 1, this is 0 factorial. So I can write this as sigma 1 over n factorial from n equals 0 to infinity. Remember that sigma x power n over n factorial from n equals 0 to infinity, this is equal e power x for each real number x, whatever x, any real number. It's not necessarily from minus 1 to 1, like the geometric series. Here, if I take x1, so I will have e power 1, so the answer is e nearly 2.7. If you calculate using calculator, so here you have 2. So if you take the addition a half plus 1 over 6 plus 1 over 2 or t4, this will approach 2.7. So let's take the next exercise. 1 plus 2 plus 4 over 2 plus 8 over 6 plus 16. So here, the first term, this is 2 power 0, up. Here, 2 power 1, up. This number 4, it's 2 power 2. 8, 2 power 3. 16, 2 power 4. 2 power 5. And down, this term, 120, it's 5 factorial. So this addition is equal to sigma 2 power n over n factorial from n equals 0 to infinity. Remember the last formula, It's x power n over n factorial equal e power x for each x. So this is equal e power 2 e squared. Next exercise, here 1 over 5 times 6 plus 1 over 6 times 7 plus 1 over 7 times 8, etc. So let's suppose that Sn is 1 over 5 times 6 plus 1 over 6 times 7 plus 1 over 7 times 8 plus etc. to 1 over n times n plus 1. So before this term, we have n minus 1 times n. So remember that 1 over n times n plus 1 could be written as n plus 1 minus n divided by n plus 1. So I can write 1 over n minus 1 over n plus 1. So I can write, this is 1 over 5 minus 1 over 6. This is the term 1 over 5 times 6. Then also this term 1 over 6 times 7 could be written as 1 over 6 minus 1 over 7. Also the next term here, 1 over 7 times 8 could be written 1 over 7 minus 1 over 8, etc. And we continue. And here we will have this term 1 over n minus 1 minus 1 over n. And finally, this term here, it will be 1 over n minus 1 over n plus 1. Let's delete this term with this term. Also, this term will be deleted. There is infinite number here to addition. Be deleted. So we have minus 1 over 6 plus 1 over 6 minus 1 over 7 plus 1 over 7, etc. So I will have finally 1 over 5 minus 1 over n plus 1. So this is Sn. What is the limit of this when n approaches infinity? It's 1 over 5. 1 over 5 is the limit of Sn. Limit of Sn means this addition. This addition 1 over 5 times 6 plus 1 over 6 times 7 plus 1 without stop. So my final answer 1 over 5. Next exercise. Here I have 2 over 9 plus 3 over 10 plus 4 over 11. We remark that 9 minus 2 equals 7. And also equal to 10 minus 3. Here we have 10 and 3. And here we have 11 and 4. 11 minus 4, also 7. 12 minus 5, 7, etc. So we can write if I call this is A. So A is 2 over 2 plus 7 plus 3 over 3 plus 7 plus 4 over 4 plus 7 plus etc. So this is sigma n over n plus 7 from n equal 2 to infinity. So if I call this term an, what is the limit of an when n goes infinity? The answer is 1. This answer is not equal to 0, so this series diverges. So this series n over n plus 7 from 0 to infinity equal infinity using nth term test. What was the nth term test? Let's remember. It's a theorem. Say that if the limit of an when n goes to infinity is not 0, then this sigma an from 0 or 1 or 2, no problem, to infinity diverges. Diverges means the answer is infinity or doesn't exist. Next exercise. 1 plus 1 over 4 plus 1 over 9 plus 1 over 16. So this is 2 power 2, 3 power 2, 4 power 2, 5 power 2. So this is sigma 1 over n power 2 from 1 to infinity. Okay, now this is converges by integral test. Because we have this rule, sigma 1 over n power b from n equal 1 to infinity, n infinity. So this is converges f b greater than 1 and diverges f b less or equal 1. Now b is 2 greater than 1, so converges. What was the integral test? The integral test said that if I take the integral of fx dx from a number 1, 2, 3, no problem. The beginning is not important. From, for example, 2 to infinity, if this is a number, so my sigma fn from n equal any number, 2, 3, whatever, infinity, also a number. Why it's not important in the beginning? Because if this sigma from 2 to infinity exists, is a number, so the sigma from 3 to infinity also exists. Now, this exercise 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5. This is sigma 1 over n from 1 to infinity. And using integral tests, this is diverges. Because it's of the form 1 over n power p and p less or equal 1, so diverges. So I have sigma here from 1 to infinity, so diverges. Next, exercise number 9. So 1 minus 1 over 2 plus 1 over 3 minus 1 over 4, etc. So this is sigma minus 1 power n over n power p from or power 1. So p is 1 here. Okay, from n equal 0, from n equal 1 to infinity. If I give n 1, I will have 1 with minus. So let's put here plus. If I give n 2, so I will have 3 minus 1 power 3, it's minus over 2, so it's correct. Now, this series converges by alternative series test. Alternative series test. What was alternative series test? If I call this sigma minus 1 power n or n plus 1 from n equal 1 to infinity times an. Here I have these conditions, the conditions of alternative series test. An must be positive, an approaches 0, an decreasing. And my an in this exercise, it's 1 over n. So all the conditions are correct. So the series converges using alternative series test. The last exercise here, 1 plus root 2 over 9 plus root 3 over 25 plus root 4. This is root 4, 2 over 49. So here, 3 power 2, 5 power 2, 7 power 2, 9 power 2. And here, 1 over 1 power 2. So here, if I take 1 up, 1 down, root 2, and here 3 is the second odd number. Root 3, third odd number. Root 4, the fourth odd number, etc. So I have here root n, so it's sigma root n over the odd number n, it's 2n minus 1 power 2. Let's give n1. If I give n1, I will have up root 1 is 1, down 1 power 2. If I give n2, I give n2, I will have root 2 over 3 power 2. I give n 3 here, I will have root 3 over 5 power 2. So this is from n equal 1 to infinity. So how to test this series? I can write this series as root n sigma over 4n power 2 minus 4n plus 1 from n equal 1 to infinity. Let's use now limit comparison test. Let's compare this series with the series sigma root n over 4n power 2 from 1 to infinity. So this series could be written as 1 over 4 outside sigma 1 over n power 2 minus 1 minus a half 3 over 2. So if I call this is from 1 to infinity. So if I call this term, this series sigma bn, okay, or 1 over 4 sigma bn, no problem. So from 1 to infinity, and here if I call this term an, so if we take the limits of an over bn when n goes to infinity, okay, I will take bn with 1 over 4. bn with 1 over 4. So now what is the limit of an over bn? It's 1 when n goes to infinity, because it's defined like this. So because this number is bigger than 0, now using limit comparison tests, sigma bn and sigma an are the same. And because by limit comparison test, and because sigma bn, which is 1 over 4 sigma 1 over n power 3 over 2, this is converges. Why converges? Because if I take this number 3 over 2, it's bigger than 1. So converges for this reason. So using image comparison test, also sigma an converges from 1 to infinity. So my series here converges, so it's a number less than infinity.